So I'm going to skip over the indirect proof part, and I'm just going to go straight to the triangle inequality stuff. So the first thing I'm going to do here is graph quickly an obtuse triangle and just try and make it as big as I can so you guys can see it. And I'm going to connect those sides together and make it so that it's scalene. So let's see what these lengths come out to be. Settings, show the value, show the value, show the value, show the value. All right, do we have a scalene triangle? Let's see. Our three side lengths are 15.26, 11, and 8.25. Lovely. The next thing I'm going to do here is put some angles in here. And we'll see how big they come out to be. They should be 3 different measures if we do this correctly. Lovely, lovely, lovely. That's what I wanted to see. I'm going to make sure that only the value is showing so that we don't get confused. And then I will be golden. All right. So the first thing I want you guys to do here is point out to me. Can I move this over? Point out to me which side is the longest side. Okay. Oh, Chancey, put our cell phones back, bud. Yeah. Hide in this class. Up there in the pockets. Thanks. Derek, which one's the longest side? BC. Very good. I'm going to highlight that in red. Okay? Who can raise their hand and tell me which angle is the biggest angle? Ben? Angle A. Very good. I'm going to highlight that in red. Lovely. Now I'm going to take the green marker. Who can raise their hand and tell me which side is the shortest side in here? Derek's already gone. Ashton?
CA.
Okay. CA. Very nice. And which angle is the smallest angle in here, Nick? Angle B. Very good. I know it's kind of hard to see. Very good. So let me open up this question to you. Where do you notice the longest side is in relation to the biggest angle and where the shortest side is in relation to the smallest angle? Owen Levitt?
They're on the opposite side of the triangle from each other.
Very nice. They're on opposite sides of each other. So you'll notice that the longest side was across from the biggest angle and the shortest side was across from the smallest angle. Now, to me, that makes perfect logical sense. If I hold my arms out in front of you right now and I make a really tiny angle with my arms here, my hands are pretty close together, right? When I open up that angle between my arms, my hands get further and further and further and further apart, right? And as I get them closer and closer together, that angle gets smaller and smaller and smaller and smaller. So to me, that makes perfect sense. As that angle opens up and gets bigger, the side across from it has to span farther. As that angle gets smaller and smaller and smaller, that side is going to shrink and get shorter and shorter and shorter. So that's our big lesson number 1 for today. In a triangle, the bigger angles are always across from the bigger sides, and the smaller angles are always across from the smaller sides. So if we have 2 side lengths here, even if I don't know anything about the angle measures, I don't know how big any of these angles are, I do know for a fact, because BC is shorter than AB, the angle across from BC, A, has to be smaller than the angle across from AB, C, and vice versa. If I don't know anything about the side lengths, but I know that this angle here is smaller than this angle here, then the side across from the smaller angle has to be shorter than the side across from the bigger angle. So in our first problem here, story problem, but that doesn't really matter too much. It says you're constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is 32 feet long. Let's just start there. Who can raise their hand and tell me if it said that sentence and this was like the ACT or something, the bottom edge of the mountain is 32 feet long. Which segment would be 32 feet long? Owen Murphy? JL. Very good. And it says the left slope is 24 feet long. Who can raise their hand and tell me which side would be 24 feet? Amy? KJ. And then the right slope is 26 feet long. Lovely. List the angles in order from smallest to largest. Now, do you know any of the angle measures? No, but you should still be able to complete that task successfully. You should still be able to list the angles in order from smallest to biggest. So let me start with Ashton. Which side up there is the shortest side?
KL. Wait, no, KJ.
Okay, KJ. Well, the smallest angle has to be across from KJ. So Ashton, which angle is across and opposite of KJ?
L.
Very good. So regardless of how big angle L is, it has to be the smallest angle in this picture. It has to be. Okay, then we go to the next side. In order from small to big, Allie, which side would come next? Okay, KL. And Allie, which angle is across from KL? Very good. So again, don't know how big it is, but I do know it has to be the next biggest angle in order from small to big. And then finally, my longest side was 32, JL, so my biggest angle has to be across from that angle K. And make sure you are putting those angle symbols. So I didn't know any of the angle measures, but I should still be able to list them in order from small to big, based on these side lengths. All right. Next example problem. Says list the sides of triangle DEF in order from shortest to longest. So this is just going to be kind of the converse of that theorem. Now, does anybody see a potential problem in here?
There is no degree.
Okay, we don't know the degree measure of F, but I can easily find the degree measure of F before I start listing out from small to big. How do I find the degree measure of angle F? Nick?
Add angle D to angle E and subtract that from 180.
Lovely. We can never forget the fact that all triangles have to add up to 100. Well, all the interior angles of any triangle have to add up to 180. Lovely. And now that I've done that, now I should be able to go ahead and list my side lengths in order from shortest to longest. Now that I know the third angle. So I gave you 2 problems on your homework where I just give you all 3 angle measures, and then 2 problems where you have to find that third angle. So just make sure that you subtract from 180. All right, Tatum is absent. Let's go. Luke, what's the smallest angle? Because it does say list from shortest to longest. Luke, what's the smallest angle in this picture? 47. And what side length, Luke, is across from angle E? Very good. So regardless of how long DF is, I know it has to be the shortest side. I don't know how long it is, but I know it's the shortest side. Followed by Owen Smith, what angle would be the next biggest angle?
Angle or side?
Angle first.
82. Or 51.
51, and what side is across from 51?
EF.
EF. So EF would come next, which leaves 82 as the biggest angle and DE as the largest side. With segment bars, because we're referring to segments. Now, if it helps you to first list out the angles, go ahead and do so. But just make sure you are paying attention to, did they say list angles or did they say list sides? Because normally they're going to list for the one that you don't have pictured. Questions so far? Okay. Are you okay if I skip the next 2 examples? Do you feel like you're okay with 1 example? If you're not, you can stick around after school. But I want to make sure I get to this next part before you guys leave for the weekend. Now, not every combination of side lengths makes a triangle. All right, you can't just pick any 3 numbers and they'll automatically close into a triangle. If I gave you a few straws or like a few spaghetti noodles or toothpicks or any kind of straight thing, and I gave you one that was 5 centimeters, one that was 2 centimeters, and another one that was 2 centimeters, there would be no way for you to connect those three pieces into an enclosed triangle. Same thing if I gave you one that was 5, one that was 3, and one that was 2. There would be no way for you to connect those three pieces and make it a triangle. So there has to be some kind of rule. Well, here's the rule, and if you're kind of a hands-on person, this might make sense to your brain. Whatever your longest side is, so in all three cases, the longest side is 5. Well, whatever your longest side is, it should make sense that the other two sides, those two lengths added together, have to be bigger than that number in order for them to intersect and touch before they ever hit the bottom side. So if my longest side here is 5, then the other two sides have to be long enough that they'll crash into each other before ever enclosing flat down on that side. If they're too short, then you'll never be able to touch them together, right? And if they're exactly equal to that third side length, that longest side length, they'll touch, but if you can imagine, they'll touch once they hit the bottom side, which doesn't make it a triangle, it makes it a straight segment. So our rule is that whatever your longest side is, the other two numbers added together need to be bigger than that number in order for them to crash into each other and enclose and make a triangle. Now, the way they explain it, this triangle inequality theorem, is that the sum of any two lengths has to be greater than the length of the third side. But you guys only need to check one of those inequalities. So I like to just kind of ignore this and just say you need to check and make sure that the two smaller sides added together is greater than the longest side. And I'll tell you why you don't have to check all three. And hopefully this will make perfect sense to you. It makes sense in my head, but that doesn't always mean much. I've chosen 3 random numbers up there. Now, technically the theorem says that any two side lengths added together has to be greater than the third side length. So you should be checking 3 inequalities. Well, if 10 on its own is already bigger than 4, don't you agree that 10 plus something is still going to be bigger than 4? And if 10 on its own is already greater than 8, then yeah, 10 plus something else is still going to be greater than 8. So the only relationship you really have to check is to make sure that the two smaller numbers added together makes a number bigger than 10. Because again, if it doesn't, then they're not going to touch, they're not going to enclose and make a triangle. So first example problem, we have 3 side lengths, 4, 9, and 10. We want to see if they enclose and make a triangle. Well, our rule is you're going to check the two smaller numbers added together and make sure it's strictly greater than the biggest number. Not equal to, strictly greater. So, Derek, what are the two smaller side lengths in A? 4 and 9. I want to make sure that 4 plus 9 is greater than 10 because the directions say decide whether it's possible to construct a triangle. So if I gave you 3 random sticks, one was 4 feet, one was 9 feet, one was 10 feet, that would be huge. But let's just say I randomly gave you these tree limbs, apparently, and said, can you make a triangle out of this? Only if 4 plus 9 is greater than 10. Derek, what is 4 plus 9? 13. Is 13 greater than 10? Yes. Okay. B. Vincent, what are the two smaller side lengths here? 8 and 9. Well, the only way this will make a triangle is if 8 plus 9 is greater than 18. What's 8 plus 9, Vincent?
17.
Is that greater than 18? No. So there's no way you'd be able to construct a triangle with side lengths of 8 meters, 9 meters, and 18 meters. They wouldn't enclose and make the figure. And then C, Liam, what are the two smaller side lengths? 5 and 7. What is 5 plus 7? 12. Is 12 greater than 12? No. It's equal, so they would eventually touch, but only once they were lying directly on top of that third side, which would not make it a triangle, it would make it a segment. All right, it has to be strictly greater. Questions on that? All right. Now, what happens if I give you two side lengths and ask you to find the range of values that could possibly be the third side length? Now, there's a reason behind why we do this. So if you get super, super curious and want to know where this little trick comes from, I can definitely walk you through it. But there is a very quick and easy way to answer this problem. If two of the side lengths are 14 and 9, then there's some third side length x. But x can't be any number, right? We have to make sure this x fits into a range of values that makes it so that the two smaller numbers added together is strictly greater than the big number. How we find that range is we're going to take these two numbers that they give us, and we're first going to subtract them. What's 14 minus 9? 5, okay? That's going to be the bottom of our range. It can't go anything beneath 5. It can't be 5 either. And to find the top of our range, we're going to just add them together. What's 14 plus 9? Bowen Murphy? 23. That's the tippy top of our range. Can't be 23, but it can be everything up to 23. So this magical side x, I don't know the length of, needs to be somewhere between 5 and 23. Now, I've written it as what's called a compound inequality. You guys learned this last year, how to write a single inequality. If that doesn't make any sense to you, that x is going to be greater than 5 but less than 23, then just write it as two separate inequalities. X needs to be greater than 5 and less than 13. I'm fine with that. But it needs to be somewhere in between there. It can't be 5 and 23 because then it would not work in the whole adding the two smaller numbers being bigger than the big number. But somewhere between there. Okay? Now again, I could explain to you, that theorem is very easy for me to explain why it's like that, but for the sake of time, I'm just going to jump straight to the little trick here. So we have a second problem. We got 12 and 20 as two of the side lengths, and I need to know the possible range of values for the third. All I do here is take the 12 and the 20 and first subtract them. Now make sure you are taking the big number minus the small number, because if you don't, you'll get a negative number. We don't have negative lengths. That's not a thing. And Josiah, what's 20 minus 12?
8.
8. Okay, that's going to be the bottom of my range. To find the top of the range, I add them. And Keaton, what's 20 plus 12? 32 inches. And x needs to be somewhere between them. Can't be them, so don't make it an equal sign as well. Somewhere greater than 8, less than 32. Now again, if you cannot write it as a single inequality, a skill you should know how to do, but if you don't, for right now, that's going to be fine. Remember, the alligator always eats the bigger number. So, okay. That should set you up nicely for your homework. You have about 5 minutes to get started. I would expect that each of you gets at least one problem done before leaving today. And that's the last section of this chapter. You will have a test again next Wednesday. Now, the first two problems seem kind of out of the blue. It says, what two statements contradict each other? I'm basically asking you to tell me which two statements can't possibly happen at the